So we are, when you point the Keck telescope at the sky, there's the main instrument to which light is going, but there's almost like a piggyback camera called the guider camera that makes sure that the telescope is pointed in the right, precisely the right spot. And that system failed last night. And you can imagine when that system fails, that's disastrous because you don't know where the telescope is pointing and you don't want to, you can't really proceed with the science observation. So we're trying to figure a workaround. Worst case, we've devised an alternate plan if this continues to give us problems. Now, what they're doing now is something called MIRA, M-I-R-A. It stands for mirror alignment. It's essentially focusing the telescope so that it's sending all of its light in to as sharp a focus as possible. And the way they do this is super interesting. It's the light comes from a distant star, hits the main mirror of the Keck telescope, which is in 36 segments. And then after it bounces off all 36 of those segments, it hits a secondary mirror. Now, they have to move the secondary mirror up or down or tip or tilt it to achieve best focus. But in the process of doing this, they actually take the 36 segments, the petals of the primary mirror, and they make it too open and too closed. And you'll see that happen. And Jim, will that be on control 1, those images?
Those will be on control 1, yes.
Okay, so in this space here, where in black and white, you see these bands, you'll see 36 images of the star that Julie is currently using to focus the telescope.
Is that what's on the left?
That's what's on the left here. That's right. These different bands here are when we took what's called a flat field exposure. These are different orders of the spectrum, Eshell orders of the spectrum, but that will get replaced with an image, with 36 images of the star.